most of you have heard this 5 times already, so here we go. Welcome to the last session of the day. This is a Georgia Energy Code update with Mike Barcik, is that right?
Yep.
Barcik from Southface. He's going to introduce himself a little more in a second. So last time, you should have that pop up for the evaluation, that chance to do it when the session is over. In this session, I will say, this is actually scheduled for an hour and a half, so we're going a little past 4 o'clock. The Energy Code content was so full, Mike begged us for a little bit of extra time. So
I'll be good. I'll be gentle.
So yeah, you'll have that chance for the evaluation afterwards. But again, if you missed it, don't worry, because you'll get an email from me with all the links later on. And Q&A, if you've got a question for Mike about the presentation, let's use the Q&A box. And if you just need to chat, ask me something, send something off to the attendees, go ahead and do that in the chat box. I hope I covered everything. It seems about right. And Mike, the floor is yours.
All right, thank you. I'm going to try to share my screen here, and I'm going to just share, I think, everything. Hopefully you'll be able to tell everything. Tell me what you see now. See the Southface website?
I do, yes.
Okay, good. I'm going to also try jumping over to PowerPoint and pulling up some slides real quick. So hopefully you're seeing a title slide.
Yes.
Good, thank you, thank you. And I am probably not seeing my questions rolling in. So Catherine, if you would be good enough to kind of monitor those and feel free to just ask questions as they come in.
Okay,
Questions that
absolutely.
need to. So thank you very much. Well, first of all, everybody, thanks so much. This was a good day to be stuck inside watching webinars. It's pretty yucky outside, so we really have had a gorgeous spring. So thanks so much for the chance to be here. I'm Mike Barcik, and I'm a technical principal with Southface, and probably a lot of you know who Southface is. I've certainly done work over the years with NARI too, presenting on code. That's me pre-COVID pandemic right there, looking freshly shaven and clean shorn. This is me today, actually that was a month ago. This is me today. So just trying to give you a sense of what I look like these days. I can't tell, I can't hear the laughter, Catherine, but I'm just assuming it's just rolling in. That's good. I come at the world from the mechanical engineering side of things, but I have a lot of experience with home construction and renovation. And there's a picture of our this year 100-year-old home. We live in a craftsman bungalow in Decatur. My wife is an architect. We met building houses and fixing houses, so we love this stuff. And I thought I'd share, when we bought our house, the first full winter we were in it, we used 575 therms of gas to heat it mostly. And the last, I don't know, 8 winters, it's been less than 200. So we're really putting into practice the efforts at improvement. I've done a lot of projects on our home. We have done a lot, but there's still a good bit more to go. And it's been a lot of fun. It's a lifetime experience. So I try to have experience talking about these things, so I can, if you're going to work on somebody's existing home, I can hopefully speak to what you're doing. As you can see by the picture, our power bills were relatively low because of a lot of improvements we've made. We were running about $1,000 for the year for our electric bills. And that was before we put solar panels on about 3 years ago. And we're, let's see, I think our last year's power bill was about $440, something like that. So anyway, it's a fun game to play, to try to keep monitoring and learning and trying new things. And that's a picture I think I shot on Earth Day. So thanks again for the chance. I wanted to point out some good resources. The slides that we're looking at here, you can download all these slides. I'm going to show you where you can get them. They come from a full day of training. We're not going to cover all the content, but this was we did about 50 full full and half day energy code trainings last year throughout the state. And so we were definitely traveling, and our new code went active January 1 of this year. So that's kind of the stuff we'll do. And so I guess my big push is go to our website, which is just southface.org. And this is where I'm going to jump out and see if I can, hopefully y'all can still see what I'm doing. And this is the main southface.org website. And if you just go into resources, there's a tab here. It says Georgia Energy Code. And usually when I click that, something good happens. It pops up. Here we go. And you can see there's a whole bunch of good information here. The slides for today you can download right here. There's a few pages out of the actual code itself. If the Georgia supplements and amendments come off the DCA website, we put them here as well. And there's some really good graphics in the supplements and amendments, and a really clean version is right here. So we'll talk a little bit about those in a little bit. And the main thing I want y'all to get is this thing called the field guide. The residential field guide is a really nice tool that I think I have it pulled up here. Looks something like this on the title. And I would describe it as a user's guide to the Georgia Energy Code for people like me that have a short attention span and don't want to read a code and would much rather look at pictures. So hopefully that describes most people on this call. But the idea was we actually wrote the book by component. So instead of, the code, if you talk about ceiling insulation, for example, it'll reference 7 different places in the code. But we tried to really make this very picture heavy and non-code language heavy. So not much on that one. Let's pick a different one. So for basement wall insulation, here's all the places where basement walls are referenced in the code. Here's what the code wants you to put for insulation. And here's a basic non-code speak description of what you're supposed to do. So, and then lots and lots of pictures. So that I think hopefully will be good and useful to you. Lots of graphics, lots of pictures. And real quick so you see what I'm talking about. And I think this is a really nice, useful tool. It's phone friendly. You can download it and zoom in on a picture real easily. It was great to kind of explain. I was trying to explain attic knee walls to somebody, and it was really great. I could say, well, pull up this thing and get this document right here, and we can just zoom in on it, and we can talk about, the need for blocking and air sealing and all this stuff. So please take advantage of this. This, I think, is a really useful tool. And again, it's got some good pictures and readable text. All right, so enough of that. Let's see. I got a couple cute questions. Okay, good. That was good. Earthcraft certification is a Beyond Code program, and that is something that you go through the HBA and you sign up for a training. It's a 1-day training, and there's a little test, and you'll be good to go. And there's go to earthcraft.org to learn more about that program. All right, where am I? A couple other things I want to mention, and along here in particular, there's some great tools in here. One in particular you might be interested. We had a lot of questions on this. Are how do I do fresh air in my house? How do I provide ventilation? There's a good little paper on how to do that. There's also a, not glamorous at all, but a useful project list of energy upgrades that you can do on existing buildings. And it really, it's kind of like questions you should ask the sub, and make sure little details don't get missed. So that's really useful. There's some training videos. There's a bunch of little webinars, but one in particular you might find useful is this one, which is about a 10 or 15 minute video on how to do a walkthrough inspection of a home at pre-drywall. So you're mainly looking at air sealing and insulation details. So I think that might be useful. I just wanted to make a pitch for some great resources. Please take it up. And the other thing I want to mention is we are doing a series of weekly webinars on building science topics, and some of these you might find interesting. We refer kind of fundamental concepts of heat, air, and moisture flow with lots of good application. a really good one about installing insulation correctly. We're going to touch on that today. And then 2 of them on ventilation, how to do fresh air. The one last week was on crawl spaces, and I think the one, tomorrow actually is on ducted mechanical systems. And then the next one is high performance insulated roof lines. So please avail yourselves of these. These are free to attend, and take advantage of it. Okay, enough plug-in resources. Finally, let's get on with it. Where are we on the code? Well, we were on the 2009 Energy Code. We were on there for an embarrassingly long amount of time. We finally changed codes this year, so that means we went active 2011, so here it is 9 years later. We're finally updating our code. It was a long process. We started with the 15, and we probably could have ended with the 18, but the reality is the 15 and the 18 IECC are very, very similar. There's not much changes in them. So I would kind of say don't worry about that. We are effectively on the same version of the code, even though technically we're referencing the 15. What do these codes look at? Mainly heavy focus on the thermal envelope. This is the insulated air barrier parts that separate conditioned from unconditioned space. So, and you'll see that not a lot actually changed there. There is heavy focus on air sealing details and on ductwork, and those did change and get more strict. One thing that's new is hot water pipe insulation, and that is something I want to touch on at the end, and also high efficiency lighting. 75% of your lighting is going to need to be, when I say high efficiency, high efficacy, just think LED, that's the right answer. And this code does not have any appliance or equipment efficiency things. Those are set by different standards. And that reminded me, I wanted to show one other thing you can get from our website. There's a 1-page handout. I think it's up at the very top. And I think I actually have it open. So let me just pull that up real quick. It looks like something I closed. So let's open it. Oh no, I had it open here. It is a basically 1-page summary of everything that changed. So if you really just want to see in a nutshell what changed this January, you can see here. And it's really not a ton of stuff, but some important things. So I think that's a great place to go. And here's the new prescriptive code. And then on the back is an example of the new Energy Code compliance certificate. So that is all there on that website. Okay, back to where we were. And one big thing I want to kind of address up front is when comparing with the old code that went active in January of 2011, probably a lot of you are aware of the fact that, or you may not be aware that Georgia was actually one of, if not the first state to require blower door testing. And at the time, you had to be less than 7 ACH 50. And we'll talk about what that means later. Years passed, more states adopted this code, and more states are requiring blower door testing. So it's really not novel like it was back then. We were a little ahead of the game. We kind of sat on it. Now we're a little behind the game. The more recent versions of the Energy Code have required blower door testing and required a tighter passing result. So we're going to see that number drop. But interestingly enough, the code required us to be less than 7. And then a couple of years later, we adopted the IRC, which said, oh, by the way, if you do a blower door test and you're less than 5, you have to have a whole house mechanical ventilation system. So without going into all the politics, our hope was that in this go around, every home would be tight and every home would have fresh air. Unfortunately, and for better or for worse, the Energy Code ended up not dropping as tight as it was originally supposed to. It was supposed to go to less than 3. We backed off and went to less than 5 for the entire state. And subsequently, another code review committee in Georgia decided that they knew more about fresh air than the code did. So they decided to change the requirement for requiring fresh air from 5 to 3. So let me summarize this by saying you had to be less than 7 and less than 5 required ventilation. Now you have to be less than 5, but due to an amendment, whole house ventilation is not required unless you're less than 3. I don't agree with that. I think every home should be tight. Every home should have fresh air, but that's where we are. So I want to make sure everybody understands that, and I'll cover that in more detail. This, for your history lesson, was our previous code, active through anything permitted, December 31st of last year. And some of these values probably look familiar. We had a certain U factor and solar heat gain for glass. Our ceilings were R30, our walls were R13. Attic knee walls were at least R18 with an attic side air barrier. Mass walls, we don't see a lot of those, but they were R5 continuous on the outside, or R8 if it was integral on the inside. Floors were R19, except a cantilever floor over outside air was R30. There's some important footnotes, cantilever floor. And basement walls in our climate zone were R5 continuous, or R13 if you stood up against it. No slab insulation. And if you condition a crawl space, it's just like a short basement. So consistency in that regard. So what I would like to do is try to a little cutaway of a house and kind of reinforce what the old code is, along with, you'll see the only few things that changed under the new code. All right, so I'm going to start with this red line right here, which is a floor over an unconditioned crawl space. So a floor is R19. Here's an exterior wall. It's an R13. Here's a cantilevered floor. It was R30. It's kind of a special floor. That was when we said we should insulate more. Another exterior wall. Here's a flat ceiling. Under the old code, it was R30. Under the new code, that goes to 38. So that's really the only insulation change is ceilings. Attic knee walls in Georgia have to be more than exterior walls, so R18. Sloped ceilings are ceilings, just like any ceiling. R30 was the requirement. R38 is the new requirement. This is a kind of a mirror image, so I'm just going to dance along here. Here's a floor over a garage. A floor over a garage would also be R19. Here's a wall between an unconditioned garage and the house. That's an insulated wall. That would be R13, unless it's a knee wall. The walls are R13. And here's a wall in a conditioned basement that has continuous insulation. That would be R5. And here's a slab, no requirement for slab insulation. And finally, last year, the windows were U factor of 0.5 and solar heat gain of 0.3. Lower is better on those two numbers. The new code, the windows got better. They dropped to 0.35 and a solar heat gain of a little bit lower of 0.27. So the upshot of all of this is that the only thing that changed is ceiling went to R38 and windows got slightly better, but really it was more on paper because everybody's already using a double pane lowy window, and just about any double pane lowy window will probably hit that, that performance level. So I'm gonna just kind of let it sink in, and hopefully you figured that out. So code insulation wise, you're gonna see not a lot of changes. And why was that? Well, for one thing, we tried to base our improvements on actual science. We actually had some really good data because Georgia participated in a energy code assessment study looking not at the whole code, but just, let's say, 8 key elements of code. And what we found here showed us opportunity to do better and opportunity for significant savings. So rather than just arbitrarily increase numbers, we actually have data to say these are areas we could do better on and what are the implications. So I'm going to give you a very short version of this study. We did not do well on, at the time, our code required half the light bulbs to be basically efficient. That was 5 years ago. Today, I think LED light bulbs are so prevalent, I think we do a lot better. But only 1 in 3 homes complied with that part of the code. In terms of blower door testing, we actually did very well. Over 90% of the homes in the study passed the code, which was great. Only a few didn't pass, and they didn't fail by much. And the median was right around a little less than 5. So the good news is we did quite well in terms of passing. The takeaway is that only about half the homes were passing 5. So we do need to see some more air sealing on this. We'll talk more about blower door testing and stuff later, but the new code is going to drop to 5, which happens to be right about the median. In terms of duct tightness, we did fairly well. We certainly had some duct systems that were leaky, but we did overall relatively well. But part of the issue was that passing was pretty easy under the old code. And you can just move that red line about halfway to the left because it's going to drop from 12% to 6%. So ducts are definitely going to have to be tighter. And then finally, insulation. What we found on insulation was most people, most builders, most homes had the right amount or a legitimate trade-off in terms of the insulation. But the quality of the insulation that was installed was generally kind of to blah. So those are some technical terms, Catherine, the to blah. And I don't know if you're going to kick in and laugh just periodically to let me know I'm still connected. But anyway, this is the lesson that we learned in Georgia. It was also consistent throughout the country. Other states saw the same thing, that the quality of the way we install insulation was not so good. And then with walls, it was particularly bad. So everybody had the quality was poor. And so as a result of that study, if you look at the 4 main areas that we want to do better on, we want to make sure we're using efficient lighting. There's nothing more energy efficient than LED light bulbs. There's nothing that pays back faster. No upgrade project will pay back faster than efficient lighting. My advice, go to 100% LED lighting, by code 75%. We are definitely going to go to a tighter house. Beating less than 5 should be pretty easy in the sense of we've been already doing it, but I get that for existing homes, it could be a little tougher. We'll talk more about how it applies to existing homes. And getting ducts tighter is certainly something that has huge energy implications. So insulation that is going to be installed correctly is a big part of what we're trying to go after. And let me see what my question is. Okay. Sorry, I'm gonna say that if we fix these 4 things or do better on these things for new homes and newly renovated homes, this is worth some significant money in a year's time. In an annual savings, it's not insignificant. So you're gonna see how the code actually addresses each of these 4 identified areas, which I like that. I like that we're using science to make a good decision.
Mike?
Yes.
Hey, you just kind of faded out for a second.
Okay, thank you for the heads up. I'm trying to think if I said anything. Yeah, it just tells me. How are we doing now?
Yes, you sound great.
Okay, keep giving me feedback if something dies, but it seems like we're back. Sorry about that. In terms of compliance, you can meet the prescriptive code, and we saw that a second ago. You can do a simple trade-off.
Hey, Mike.
Within the envelope. People still failing?
Yeah. Well, just like it got real slow.
Okay. All right. Well, I can't think that fast, so that's probably good. I'm gonna keep trying. I'm gonna keep trying, but let me know.
It sounds fine now. Yeah, it sounds fine now, but when you start talking about content, it
yeah, of course,
shut out.
That's naturally. So anyway, you have 3 compliance options. Those are still around. In the new code, we have a new compliance option, which is called the Energy Rating Index. And if you're ever with the Home Energy Rating HERS Index, it's basically the same thing. So this is a new compliance option. This is if you just follow the recipe. This is very simple trade-offs within the envelope. This is a more sophisticated computer simulation, but none of these trade-offs allow you to take credit for things like a more efficient air conditioner or a more efficient furnace or better water heater. But this approach looks at all energy used in the home. So this might be something that you want to use for a beyond code program, or just for a more sophisticated house that has lots of features in it that is going to be hard to comply with, say, the prescriptive code. Okay, just a quick recap. This is the prescriptive code. This is the better windows and the slightly higher ceiling insulation, and everything else stayed the same. So I'm going to just try to hopefully make sure people are hearing that. And Catherine, please do kick in if you're having trouble hearing me.
Yeah, no, you're good. Good right now.
So far, so good. The code focuses heavily on doing the building thermal envelope correctly. And again, that's the boundary that separates conditioned from unconditioned spaces, particularly in existing homes like you folks are always dealing with. Sometimes this boundary is not so clearly defined, but it needs to have a continuous air barrier and insulation as well. So that's and trying to get this done right. And just as an example, here's a little thought problem. If you can imagine 3 identical looking homes from the outside, example 1 is kind of the more conventional approach, where they've insulated the flat ceiling, the walls, and insulated over the foundation. Example 2, it looks like they cathedralized part of the roof, but they still have an attic space. This one has a knee wall and a flat ceiling. And it also, now they've chosen to bring the foundation into the building envelope. And example 3 over here, it looks like they probably did something like spray foam the roof line and included the walls of the foundation as well. And the reason I'm gonna ask a question, Catherine, so you got to tell me who answers this question. So we're ready for a question here.
Okay.
If you can imagine that there's a mechanical system that's located right here, and there's probably another one that's located down here. So X and Y are ducted mechanical systems. If all else is equal, and you've got house 1, house 2, house 3, which of these 3 houses is going to perform the best from an efficiency and performance standpoint? I'm hoping we get some right answers on this.
Someone says 3. I'm seeing 3s all over the place.
That is terrific. Well done. That is exactly correct. House number 3 is going to outperform because the number one thing we can do to make a house more efficient is get the ductwork and mechanicals to be inside the thermal envelope. And you can see in this house, and just as an added bonus, if this is a new duct system, these 2 are going to have to be leak tested. Neither one of these, you kind of get a get out of jail free pass. You get a do not have to test the ducts pass. The ducts still need to be sealed, but the ducts are all inside the envelope. So you don't actually have to do a duct leakage test. And obviously this one has to be tested, whereas this one's inside. Just one other quick thing, if we're blower door testing, it's kind of an FYI, what we're really testing is the air tightness of the blue line. So if you can imagine an attic access door here and a door, say, down to the foundation here, if you're testing the integrity of the blue line, the doors would be closed in house number 1. The doors would both be opened in house number 3 because we want the volume to be well connected. And here in house 2, that one's closed, that one's open. So just FYI. Jumping into the code, section 402.2 has traditionally always been the kind of read here for more instructions part of the code when it comes to insulation. It's broken up by component, and I've bolded, and we'll probably talk about the ones that are in bold because they're the ones you're more likely going to see in a more typical home. And it's like I said, it's kind of read here for more instruction. And in some cases, Georgia made a few amendments to these sections, but this is how the code is laid out. I guess I probably should have mentioned too, if you see an icon in the upper corner, it means, okay, that's a Georgia amendment and it's also in the code. Something, if it's one or the other, you'll see that. So as we've mentioned, Georgia made R38 the prescriptive code requirement for the whole state. And we still have a provision that says we're not going to make you do a trade-off if you have one 4x8 sheet of OSB on a raised platform, as long as there's at least R19 under it. So we're not going to make you do a full R38. Absolutely best practice is to elevate it like you see in this picture where you can get the full R value. but you got to do at least R19. We won't make you do a trade-off. And probably most people are familiar with this, the attic rulers and some of the details on that, a proper insulation install. One thing I did want to touch on is, and this is in the code itself, is the code basically says you're supposed to have R38, but if you do a continuous R30 that fully covers the entire ceiling, that means over the edge of the top plate, like you see in this picture, we're going to let R30 continuous, in essence, be deemed to comply with a prescriptive R38. So this is interesting. If you have a situation where you can frame it and get the full R30 everywhere, you actually are still meeting prescriptive code. So that was news to a lot of people, but that's part of the code. Also, some other details about the insulation dam at the eave. That has to be everywhere there's a baffle. The baffle needs to vent and go at least 4 inches above the top of the finished loose fill insulation. And this is real important so that we don't have what's called wind washing, where wind can essentially whoosh through your fiberglass or your cellulose or whatever and really kill the R value. And we're going to vent the attic. That's fine. We're just going to vent above the insulation and not through it. So little details. If you want to do a ceiling without an attic, a little bit of cathedralized ceiling, up to 20%, or rather 20% up to a maximum of 500 square feet can, let's say you just got a little section of the master that you're going to vault. You can do R30 there and not have to do a trade-off. That's just built into the code. If you're going to do something like foam the roof line, you're definitely going to need to do a trade-off. And no matter what, when you foam the roof line, you have to do at least an R20. That's the minimum that you can essentially trade it down to. The code never says spray foam. The code says air impermeable insulation. So if you want to do air impermeable insulation, and these are, a lot of these graphics come right out of our appendix for our energy code. So anyway, R20 is the minimum. There are ways to do, I like to call them hybrid systems, where you can use a combination of a, let's say like a spray foam or a rigid foam board, and then a air permeable insulation, such as fiberglass batt, for example. So the minimum in climate zone 3 is you could put a continuous foam board, say above between the decking and the rafters. There are products that nail-based products that do that. You could put a foam board in here. You could spray an inch of closed cell foam, something to get you an R5 in this space, and then put, say, as low, you have to have at least an R20. Again, your prescriptive code is 38, so maybe you do an R5 here and you do an R30 batt, and then you're almost at prescriptive code. Those kind of things would allow you to do a hybrid approach. This is allowing you to do a vaulted insulated ceiling assembly that does not have any venting in it. If you choose, you can still do the old classic, chutes and ladders kind of thing with the vent baffles, and you got to have a dam so the air doesn't wash through your insulation. You got to have the vent chute, has to go all the way up to the ridge. And at the end of the day, you gave up an inch for this vent baffle. Personally, I think if you're going to put insulation on the roof line, you're better off doing something like this or spray foam, but all are allowed by code. And if you have more questions about this, I'm going to say tune in next week to this particular topic. We're going to talk about high performance insulated roof lines.
Hey, Mike.
Yeah.
We got a question. How does the energy code relate to remodeling versus new construction?
Very good question. And I was going to kind of talk about that a little bit more when we got to the blower door testing, but the short version, I'm going to tell you right now, it's a very good question, by the way, is that all new work needs to meet code. So if on a renovation you mess with it, you need to do it to code. If you do not mess with it, then you're okay. If you are remodeling the kitchen and you strip the walls to the studs, you're going to need to air seal and insulate those walls. But if you're not messing with the living room, you're not obligated to go back and air seal and insulate those wall sections. That's just an example, and we can try to look for more applications of it. But the short answer is new work needs to meet code, and there's a couple places where you kind of go, well, do I have to do a blower door test or do I have to do duct testing? I'm going to cover that in just a little bit. Great question. Okay, let's see. I'm going to drive on, Catherine. Thanks for the interruption.
What? There's another one. Do you want to see if this is appropriate?
Yeah. Currently doing a project with a flat roof, 2x8. How do you meet the R? You may have a hard time meeting R38 unless you did a combination of closed cell foam and maybe another type of insulation, given that you're constrained by that. You may choose to do a trade-off, Chris. So that's an option as well. But I would try to hit prescriptive, or at least R30 if you can. But if you do spray foam, you're going to have to do at least R20. And we'll, without trying to go too deep in the weeds, you can get an let me go back to my presentation here. You can get an R20 with open cell foam in about 5.5 inches. You can get an R20 with closed cell foam in about 3 inches. So you may want to lay down, some closed cell foam and then some other insulation and see what you can get. Let's see if I knew this was going to happen. Whoops, I hit the wrong.
You wanted to answer them.
Yeah, no, that's okay. It's all right. Need to blow a ranch attic of 1,100 square feet next week. R38 is new, but there's an exception if you use baffles and insulate R30 over the extra. So let me see if I can go back to that. So basically, this is not me. This is the energy code. It says if you can do a continuous R30 everywhere, that is deemed to comply with effectively a tapered R38. So the answer is if you can truly get R30 everywhere, you can show that that meets prescriptive code. As long as it's truly R30 everywhere, you have met the prescriptive tapered R38. Good questions. I'm going to keep driving on, and we can throw more as keep them coming. Okay, so attic access, no real changes here. Attic knee wall doors, R5. Attic pull down stairs, R5. That's what most builders do. Scuttle holes or hatches, you're going to do an R19. And if you have mechanical equipment up in the attic, you pretty much have to have a pull down stairs. So that is another code requiring that. Most builders we see are doing something like this, where there's a stairs with a weather stripping around the edge and a foam board in the door. Certainly never hurts to do more. You can do a cover as well as this, but the minimum is R5. The floor insulation details, really no change here. The challenge with floors is getting insulation to stay up against the subfloor. It's very hard to do that. I'm not a big fan of insulating a floor, but no real changes there. Basement walls, definition of basement wall is more than 50% below grade. So we see, of course, a lot of walkout basements in Atlanta. And the idea is that you have to choose where is your building envelope. Is it going to be air sealing and insulating the floor, which, as I said, is hard to do well, or are you going to air seal and insulate the walls, which is my preferred approach? Mainly because there's usually mechanicals in the basement and you've now brought them inside the thermal shell. So if you're going to do this in climate zone 3, you have to have an R5 continuous on the concrete or stud up against it with the R13 cavity. I prefer the continuous. Here's a couple strategies. There's rock wool products that you can glue to the thing. There's a cellulose bat you can glue to it. There's a perforated vinyl backed roll of insulation that you can attach to the concrete with furring strips or fasteners. There's some foam board that you can actually leave exposed. It's a foil-faced polyisocyanurate foam board. That was easy to say. Other foam boards, you're going to have to cover them with drywall. So if you're going to finish the basement, I think this is a really good way to do it. This system has a shiplap joint that allows you to put a furring strip in there and then you cover it all with drywall. You're only looking at about an inch-ish to get the foam R value that you need. So that's a good option. Here's some, if you're not going to finish the basement, but you still want to insulate the walls, This is a trick using those rolled blankets. It's the same kind of insulation you would find in a metal, like a Butler building, a metal building. And it's a draped blanket. You see, we folded it and button cap nailed it at the sill, did air seal and insulate the band, draped it down, taped the seams, put a pressure treated plate on the floor, cut off the extra. It's not a finished basement, but it is essentially a conditioned basement. And it's a great way to do it. So a little bit on basements. If you run into crawl spaces, you're still allowed to do the classic vintage 1970s vented crawl space with underfloor insulation. It won't work well, but you can do it. You can do a closed up crawl space with underfloor, but if you're going to close up a crawl space, we generally say treat it like a basement and insulate the walls. No real changes here from what was in the code, but just to clarify it, unless it's a very, very highly vented crawl spaces, any crawl space has to have 100%, they call it a class 1 vapor retarder. It's basically 6 mil poly, run up the walls, sealed on the overlaps and seams, etc. And then to make it unvented and satisfy the code, you need an R5 in climate zone 3. You, of course, are not going to vent this crawl space, and your access doors have to be treated like an R5 access door that's airtight. And then the code basically says if you're not going to vent it, you either need to continuously exhaust from it, or better, that's probably not the best way, is to condition it. You can condition it directly with supply air, or you can condition it with a dehumidifier. My preferred approach is the dehumidifier. And again, vents or no vents, don't try to, accept a crawl space with stupid, dumb drainage problems. And too many houses in Atlanta have that. So I'm sorry you've inherited the mess that Atlanta produces, but fix them. And also you can't use vents in the crawls. We just did a whole hour-long webinar on this topic last week, so I'm on my soapbox. But if you are going to have combustion equipment, it can't be standard combustion equipment. It has to be sealed combustion, like a 90% firmness, and it's got to have the 2 PVC pipes going to and from it. And we want to make sure the pest control people are satisfied, so we insulate the wall, run it down, but you need to leave a view strip for the pest control people. We recommend you put a plug of insulation in there, and we just tape the bottom of it, and that way you can fold it down, and then the pest control people can fold it down to inspect, but they can also hopefully push it back up. If you can imagine from a heat transfer standpoint, heat's going to conduct where there's no insulation. And so we really do want to try to do that. That's best practice, highly recommended by Southface, not required by minimum code. And the other big issue is the band area. From an energy standpoint, shooting spray foam in here is a beautiful thing. But from a pest control management standpoint, that's really hard for them. So we recommend, to make them happy, we're going to air seal that, probably with caulk or a little bit of can foam. And then we're just going to put a removable bit of insulation in the band. This is always going to, I think you can squirt foam in the band joist between the first and second floor, but when it's your foundation, your rim joist, put a pillow with insulation in it. That's another option. Okay. Hopefully I have made a pitch for why we don't want to do underfloor insulation. I'm sure you guys have seen these kind of problems before. My wife took this picture. You just look at it, and look at all the plumbing and electrical and ductwork that's kind of in the way. And look at how gravity or a subcontractor, got in the way of holding this bat up here. And then look at these walls, and look how easy it would be just to insulate these concrete walls and not mess with the floor. You just got to believe me. This was a big retrofit project that I did on my own house, but the comfort improvement was unbelievable. It was so much, it's so much warmer on our floor now because we're not venting cold air into the crawl space. And our heating bill in our house dropped 40%. So I don't know if everybody's going to get that, but it was significant. No real changes on windows other than on paper. The U factor and the solar heat gain are consistent statewide. So a window anywhere in Georgia is going to pass anywhere else in Georgia. And it is a weighted average. So it's possible that, say, most of your windows are a little bit better than code. A couple of your windows are a little bit worse than code. And the weighted average is still going to pass code. Looks like I knew we'd get some window questions. what percentage of building officials are qualified to understand these nuances. I like that. Or it's nuisances. I can't tell. Was that nuance or nuisance? I'm not sure of the intended meaning there. We have done extensive training for code officials, and we continue to do that. We also have an energy code hotline on that same website. So if you're having challenges, I cannot make a person change their mind, but I am happy to show them if they're willing to listen. And we certainly try to do that. Also, we partner heavily with the Department of Community Affairs. A guy named Jimmy Reynolds is their technical guru there. We try to make sure we're always sending a consistent message. So hopefully that helps. And we'll see what the nuisance or the nuance is. I think it was nuisance. If you stay prescriptive, meaning everything you do is prescriptive, you get a couple of freebies. You get 15 square feet of decorative glazing, in essence, that's exempt from the code. That's only if you're only prescriptive. If you do trade-offs, you have to account for it. And likewise, same for doors. Doors are supposed to be a 0.35 U factor, which is just hand wave here, about an R3. A wood door is probably an R2. You get one free wood door. You don't have to do a trade-off. The only provision is that door cannot be your attic access door. So that was a good one.
Hey, Mike.
Yep.
Since I just heard you say trade-off a couple of times, we did have a question. What do you mean by trade-off?
When I say trade-off, I mean you're not meeting the prescriptive insulation requirements of the code. A good example would be you're only going to spray R20 along the roof line. You're not going to spray, or you're not going to do an R38. So steel windows, I just got a question about that. I'm hoping that what you mean is aluminum clad. If they're metal clad windows, they generally have the same performance as a vinyl or a fiberglass frame. Steel frame windows take a big hit because of the conductivity of steel. And so really the worst windows out there are the old single pane metal frame windows. So anything you can do to upgrade those on an existing home is probably good. Although I also want to say, in and of itself, upgrading windows is a very long payback. I get it. People like it. So if you're going to upgrade the windows, do it for aesthetic reasons, and there'll be a little bit better comfort and some energy savings for sure. But if you just look at in terms of upgrade tasks on an existing home, it's a very long payback. And I'll just tell you, my 100-year-old home still has the original single pane sash weight wood frame windows. I do have storms on them. They were already there when I bought the house. Yeah, they're kind of ugly, but you know what? They work, and we don't have any, condensation on to speak of. So steel in the higher end homes, typically they are made and shot by the hand. Steel frame, you're going to take a huge hit if your windows are not rated, and even if they are steel frame. So again, on the trade-off topic, if you don't meet a requirement on a door, you can make it up on an upgrade somewhere else. That is correct. I tell you what, I'm gonna keep driving in. What about more than one exterior? By the way, glass doors are treated not as opaque doors. So this is for opaque doors. Glass doors basically are the same as windows. If you buy a new, double set of French doors or whatever, they're most likely going to be equivalent to a double pane low E. So they're going to actually do just fine. Let me see if what else have I got? In a crawl space with permanent. Yeah, with permanent wood foundation, is there a different code than a regular? Nope, it's the same for an all. When I was building houses, we were still doing all-weather wood foundations on some of them, and you could insulate them. If it's a cavity, you can insulate the cavity with R13. If it's continuous, it's R5. Obviously, there you really do want to pay attention to your moisture details and your inspection capability. Good questions. I'm going to keep going if that's all right. Thank you for the great questions. I want to make sure we cover air sealing and insulation details. This is very similar to what was in our old code. It's basically a checklist. This comes right out of the code itself. And this checklist is mandatory. You have to comply with it. And what Georgia did is we actually put a few little extra details into it, and mainly we put numbers by it. And so the numbers correspond to pictures. There's about 20 pages of graphics to help demonstrate these things. So, you know, our code is in many ways a lot more easier to follow than just text. And I think that's a good thing. Walls, for example, it talks about places to air seal, the foundation and the sill plate, the top plate, the knee walls. It's kind of vague the way it describes that. So that's why I think pictures help a lot. But here's an important one. It says, cavities within corners and headers of frame walls shall be insulated by completely filling those cavities. So you cannot, no longer can you frame a wall and you know, have blocks in a 3-stud corner and leave that. Our little training video I showed you earlier has some good examples of how to address that. So you need to be aware of that you don't want to have to drill a hole and try to fill up those cavities with foam. It's much better to frame it where you just turn the 3rd stud perpendicular, and then you can get insulation in the cavity. Lots of details on that graphic. So just examples of some of the graphics that come in that section. I'm going to show you. This is a newer, some of them we've had in our code, like the knee wall one. Some of them are newer. Here's a way to frame T-walls. This is one where you have an attached garage, let's say on a 2-story house. Here we're in the kitchen here, and you can see the blocking, the air sealing of the blocking, and then the insulation. That's a real critical detail. Blower-door testing, as I mentioned, the single family answer is less than 5 ACH 50. And it turns out every home has one number that is how much air you have to basically suck out to create a pressure difference between the inside and the outside of 50 pascals, which is a certain amount of pressure. And that's the test condition. So every home has one unique number called the CFM 50. It's how much air does it take to get you to the test condition. So if you slam that number into this equation and you multiply it by 60 minutes in an hour and you divide it by the volume of cubic feet of the house, the conditioned volume of the house, that will give you the air changes per hour at 50 Pascal. By code, you have to come in at 4.99 or tighter, that kind of thing. And no changes on who can do the test, DET verifier, people that know how to have been trained to use the equipment. I'm going to kind of cut to the chase here that the one that you're probably interested in is this. There's no change on this. If you do a partial renovation, all new work needs to meet code. Air sealing needs to be done per code. If you do a full renovation, all air sealing needs to meet code, and you must pass a blower door test. So it really is about a gut renovation on the whole house versus a partial renovation. But in all cases, air sealing and insulation has to be done per code. I hope that helped kind of reinforce that question earlier. I think we touched on this, but this is the new looking certificate. It typically is, I know a lot of people put it on a plastic sleeve that goes inside the, usually it's inside the electrical panel box. And it talks about, the top is usually filled in by the builder. It sort of says, what's the primary insulation for each of these components? The middle part is, you know, I've got a gas furnace, it's this efficiency. I've got an air conditioner, it's this SEER. And if I have fresh air, here's what I'm doing. And the bottom part is where we put the blower door test results and the duct tightness test results. So we like to teach people how to fail. That's our goal in life. No, we're going to try to learn from failure. And I thought we'd show you some pictures and some kind of good and bad juxtaposed here. So here is a bad failure. This is a home under construction. They did, it looks like 2nd floor jacuzzi tub set against a porch, maybe on the 1st floor. And you can see they did not run the sheathing all the way down. This is basically an attic space and no air barrier at all. No air barrier here on the outside. And by code in Georgia, the insulation has to be completely surrounded by an air barrier. And you can see the pathway for hot, humid air in the summer to get in between floors and cold air to leak in between floors in the winter. So how do you fix that? You sheathe it all the way, insulate it properly, and then air seal it on the inside. Here we're using a thin air sealing material called Energy Brace, and you can notice it's been sealed. Here's a cantilever floor. No blocking was shown here. They tried to shove insulation in, but that doesn't act as an air barrier, and it's all wrong. So the blocking we're talking about, it can be wood, it can be foam board, but it's got to be sealed in place like you see in this picture. This was a house that had a cantilever porch. I just was trying to demonstrate two different ways of, here it's not been sealed, here it's been blocked with wood and foamed, here it's been using foam board and additional foam. Any of those two options are great. You want to fail a blower door test, leave a giant hole like a chase. You're probably going to inherit some of these when you do renovations. And the trick is to cap the chase. You'll see them with ductwork as well. It's really hard to fix this. Honestly, you got to cut a piece of Swiss cheese, probably foam board, to go around this and then try to make it airtight. It's much easier. Thank you for laughing. It's much easier to cap the chase completely and then have the subs cut the hole they need, and then you can seal it. Still plate penetrations through the top and bottom plates. And of course, make sure the plate is sealed to the subfloor or to the slab. You can use sill gasket, you can caulk the inside edge, but this is really critical. And I thought I'd show you an example when you probably run into this, I'm guessing, on your existing homes that you look at. I bet if we did a survey, I bet there's a number of people here that have seen white carpeting with dirt on the edges. So Catherine, let me know if anybody buzzes in with saying, yes, I've seen that.
Let's see.
Yeah, the clock is ticking. But anyway, if you see that, if it's an exterior wall, that's because the bottom plate was not sealed. If it's an interior wall, it usually means that the interior wall cavity is leaking to the attic at the top. And we really can see this if we use a blower door on a hot day and have a thermal camera. What happens is all that hot attic air gets sucked down, and really the wall, the inside wall here is degrees. It's crazy. So that is the sort of the tell of an air leak on an existing home. Here is an existing home that has an attic knee wall. This attic knee wall does not have any blocking under it. It does also not have any sheathing on the vertical attic knee wall. I'm going to keep going here. This knee wall has been sheathed, but no blocking. And this is what we want to see: the blocking and the sheathing on the back, and a sealed attic air barrier. And the total R value of the knee wall insulation needs to add up to be at least 18. So you can frame it as a 2x6 and sheath it with OSB. That'll be an 18. Or you can do a 2x4 with foam board, some combination that gets you an R18. Here is a picture of it, one way that has been done. Let's see. I thought maybe I had a question. All right. As I mentioned, we learned that our insulation industry can do better. So we chose to address this in Georgia by writing a performance spec for the code official, because it's kind of weak. It's in the code there. It's been in the code. It says all insulation has to be installed the way the manufacturer wants you to. But that's a weak statement. So what we did is we wrote a spec, which is basically a go, no-go spec. And it looks at the two main things that affect insulation performance. One is voids or gaps. This is places where you can see all the way through. You can actually see, light behind it, or you can see the sheathing behind it. That's a void or a gap. And the other one is there's some insulation, but it's been compressed, or it hasn't been, installed the right amount, and it's supposed to be 3.5 inches and it's only 2. So those are the two big issues that we want to look at, as well as is the insulation in contact with the air barrier. And in this infrared image, hopefully you can tell we're in the attic. It's the winter time, and you can see that is not air leakage that we're looking at. That is the bat not touching the drywall. And try to imagine it was a floor. Again, why is it so hard to get floor insulation to work right? Because it's got to be right up against the subfloor. So those are the kind of key elements. Imagine my sadness. I walked into a home being renovated for one of my friends, and I looked up and took this picture. And this is the really crappy insulation job. And hopefully you see the problem here, that the bat is probably 4 or 5 inches above where the drywall is going to be. It's a terrible analogy, but maybe Catherine will laugh and make me feel better. Try to imagine it's cold out and you're trying to sleep under a blanket, and in the middle of the night, the blanket levitates 6 inches above you. It really doesn't keep you very warm. Catherine, you're the best. All right, thank you. So we wrote a spec. The spec is how to install insulation correctly. It says voids and gaps have to be less than 1% of the entire insulated surface. Really none is what we're looking for. And compression or incomplete fill has to be less than 2% of the surface. And also, the amount of compression can't be more than 1 inch. So we wrote a spec, and this is all in the appendix of the Georgia Code. We wrote a spec. We put diagrams and graphics to kind of illustrate. Here's voids, no voids, lots of voids. Compression, no compression, lots of compression, that kind of thing. And then just while we're at it, so here's a picture of it again where you see compression and you see voids. So this is not compliant. Just to be clear, I want to make sure everybody hears this. There is no requirement anywhere in the state of Georgia for vapor in walls or ceilings. So you can use unfaced.
Say that one more time.
Yeah, that's important. There is no requirement for vapor retarders in walls or ceilings anywhere in the state of Georgia. You can use paper face bats if you want to. Our preference, frankly, is to use unfaced because we, not necessarily in this picture, but we typically see better installation with unfaced insulation. The paper facing is completely optional. So I just want to get that out there. If you're going to use paper facing, I would much prefer them face staple it or barely edge staple it like you see here. Most of the compression that we see in fiberglass is because people shove it in and hammer staple it. But unfaced, I think, is just easier to inspect and easier to make sure it's done right. There's some great videos, this thing called YouTube. It's amazing. Here's a quick summary of, good, thank you. Here's a quick summary of what we're looking for in terms of performance. Filling the cavity completely. Make sure it's in complete contact with the air barrier on all 6 sides. Don't leave any gaps. Split it around wiring and plumbing. And then if there's an electrical box, cut out a notch for the insulation, put that piece you cut out behind the box. Here's pictures. So here's a picture of the ceiling where it was done right. We see dam vent baffles going up above. We see a dam around the attic access. We see the rulers. We see the report card. We see the right kind of can light fixture, airtight and insulated contact. We see a good picture. We juxtapose with a bad picture. We look at ugly pictures. So hopefully this is driving home this kind of performance. It's so sad when, you know, people spend a lot of money on this renovation and, you know, move into this lackluster renovation and this is what they get, or a new home for that matter too. So I'm not trying to pick on renovation. There's also a spec for floor insulation. Okay, driving on. Just want to be real clear on this. The code is finally taking a stance on the fact that we're building tighter houses and we cannot get combustion air from people air. So it is absolutely fine to put in an atmospheric vented water heater as long as it's in a sealed off chamber from the people of the house. And then you provide, I always call them high-low vents for combustion air to get to that appliance. It's essentially like saying, I could move this water heater up into the attic that's vented, or I'll just move the attic around the water heater and I'll seal it around that way. That's another way of thinking about it. Obviously, you can also move that water heater out to the garage. You can upgrade that water heater to a direct vent or a sealed combustion. There's lots of options here, or all electric, you know, there's lots of choices here, but do not mix people air and combustion air. And here is a really good example that I'm guessing a lot of people on this call run into. I grabbed this from another presentation, but if you're going to foam a roof line, which is from an energy standpoint a great upgrade, do not use a standard 80% furnace. You may know how to look at this, immediately tell this is 80%. I'll give you a hint. It's using the air around it to burn with, which we don't want to do, and it's got a metal flue pipe. This one is a condensing furnace. It's a high efficiency furnace. And notice it's got 2 pipes. You got to have 2 pipes in a foamed roof line. One pipe brings fresh air or outside air in. It's sealed in a chamber. It burns, and all the exhaust products are pushed out the other pipe. That's the furnace you want to install in a foamed roof line. Does anybody have any questions on that? I want to be really clear on that. Question popped up. Can I have a tankless water heater in the crawl space? Yes, if it is, and the same goes true for crawl spaces. If it is the type of water heater that has the ability to bring its own combustion air in, burn, and exhaust out. Some of those are done with two different pipes. Some of those are done concentric, meaning a pipe inside of a pipe. So the answer is yes with that provision. Do not use, I'm sorry, let me back up. I was speaking as if it was a closed crawl space, and maybe that was the question. If it's a conditioned closed crawl space, the answer is it has to be the right kind of water heater. If it's a vented crawl space, you can put any stupid thing you want in there. But I'm saying don't do that. I like it when you can tell when I'm offering commentary. So, okay, good question. I think we touched on this. No change on the code. Can lights pretty much the same as we've been seeing. Airtight and IC rated if they're part of the envelope. Okay, we talked about all the insulation and air sealing details. If you need to do a trade-off, I'm just going to very briefly touch on the ways to do trade-offs. Historically, you would have potentially used ResCheck, which is free, and I'll show you where you can get it. The problem today is ResCheck assumes you have to tell it which code we're using. You have to assume the 2015 code. And when you select that for Atlanta, which is climate zone 3, it's going to assume your exterior walls are R20. And that was a change Georgia made. We weakened the code by staying at R13. So you could use ResCheck if you can make it work, great, but just be aware that you're held against a harder code than the actual code. There's where you get it. No Georgia specific version. So I don't think you're going to want to use ResCheck. There's also a free, I'm going to call it it's a hand version of ResCheck. If you know how to use an Excel spreadsheet, you can grab that off our website. There's also a little webinar on how to do it. It will allow you to do trade-offs, but it knows the walls in Georgia are through. You can also do this simulated performance thing. This was always in the code. You're probably going to have somebody like a HERS rater do this for you. And it's an analysis as well. The new one that only a HERS rater really can do is called the ERI. And the ERI is kind of unique in that for the first time ever, you would get credit if you put, for example, an energy recovery ventilator in the house. This is a fresh air system that's more efficient. Or if you have a more than minimum efficient furnace, like this is a condensing furnace. Or if you're the builder and you set a Energy Star refrigerator. Or if you put in 100% LED lighting, which by the way, you should do anyway. There's no excuse today to not use LED for everything. Or if you're a builder and you set a dishwasher, and it's just about every dishwasher is Energy Star, or you put in a more efficient ceiling fan, or even if you put in renewables, all of these essentially can show up and credit you in the new approach. So without going too deep in the weeds, the way it works is someone's going to take a set of your plans, a HERS rater is going to take the plans, they're going to run them. The home that you propose to build is called the rated home. They're going to simulate it. And the software is going to look at all the energy required for 4 things. Heating, these are made up numbers, cooling, water heating, lights and appliances. Then it's going to take your exact same plan and it's going to build it as if it was 2006. It's going to take it back in its time machine and build it to the reference code, which was the 2006 energy code. So these are just made up numbers. Those added up to be 150. And let's just say, oh, it was 70 and 20 and 30 and 80. So 200. And what happens is your ratio of the rated over the reference home in this example is 0.75. You multiply it by 100, your index would be a 75. What that 75 means is that your home uses 25% less energy or is 25% more efficient than the reference home, which in this case is always the 2006 energy code. You do not have to do this for code compliance. If you're going to do this for code compliance, you got to get a much lower number. You got to get down to 57. But this is just how it works. And just by the way, there's also a multiplier for renewables in here. So that can lower your output as well. Here's our target without going too deep in the weeds. 57 is what we're trying to achieve. And I'm going to just show an example. So I took a house that I had some plans for. It's a 2-story, 2,800 square foot, 5-bedroom house. You can see the basic floor plan there. It's got an attached garage. And I ran it through 5 years ago, and I got a HERS index of 85. I ran it through this year, and the same home get a HERS index of 80. When I built it, I should have said last year, when I built it to this version of the code, it scored an 80, whereas it used to score an 85. Does anybody know what happened to air conditioner efficiencies over the last 5 years? Let's see. I don't know. Catherine, does anyone know? I'm just going to answer my own question.
Yeah, nothing yet.
Yeah, everyone's still thinking it's close enough to cocktail hour. It's dropped. What happened was the SEER of air conditioners went from 13 to 14. So that's why the index dropped from about 85 to about 80 for that house. So then I tried running it through, if I just met the prescriptive R values and then had the right amount of efficient lighting, that dropped it into the mid 60s. And then if I put in a more efficient furnace and air conditioner and probably efficient lighting, I could get it down into the mid 50s. So it's just, what it's really saying is we don't care how you get to the finish line. You just got to get to the finish line of 57. And whatever methods or materials or components or equipment you put in, anything better than code, you're going to get credit for it. So it's not a cakewalk, it's not a freebie, but it is a neat way to show how efficient your home is, both before and after renewables. And so, like, if I took this home right here that was an 80, and that's my roof right there, that's 15 solar panels. That was about a 4,000 watt or a 4 kW array. So probably about 18 panels would give you a 5 kW array. So I could just take that home and put, 20 solar panels on it, probably less, and get to the passing point. And that's probably not how you're going to do it. But if you also took a more efficient home, like that one, if you started in the mid 50s and you started putting solar on it, you can see, you can get your index to start dropping lower and lower and lower. And okay, Catherine, I'm going to ask a question. Does anybody know, what would it mean if my home had a HERS index, not of 13, but what if my whole HERS index was 0? What would that mean if my energy rating index was 0?
Let's see, nothing yet.
Yeah, that's because
They're
everyone
typing,
is
they're all typing.
dead. Okay, good. Yeah. Someone, let's see if anybody can buzz in with the answer.
Sealed too tightly. You live underground.
Underground home, sealed too tightly. These are good joke answers. I like that. Okay, all right.
Perfect.
The answer is you would be a 0 energy home, because what it would mean is you would still use energy, but you would offset it with what you produce. In fact, it's possible that you can have a HERS index of a negative number. And by the way, this has already been done in Georgia a couple years ago. And what you do usually is you build a very efficient shell and you put very efficient appliances and equipment in, and then you put some solar panels on it. And that will get you, if you have a negative, let's say a -5 on your HERS index, that means in a year's time, you actually net produce more energy and send back out more energy than you consume. So it has been done, it can be done. And, gosh, if the renovator community wants to lead the way on this, I mean, we got to fix a lot of existing homes, but this is a great, sort of target for us to have.
Do you want to answer a question about solar panels real quick?
Sure, hit me. Let's see.
What is your break-even year for your solar panels? You paid X for solar panels, you save $500 a year.
Yeah, that's a very good question. By the way, I try to be very transparent with that, and I'm going to go give you the thriller version of this. Let me see. I got to get back to my screen here, where I can actually. You have to tell me if you can see this, Catherine. I'm going to pull up my my solar array. Not much happening today. Not too exciting to look at today. Can y'all see that? The blue is my production, and guess what? It rained, and the orange is our consumption. So we did not make very much today. This was yesterday. It was also pretty kind of iffy yesterday. We made 13, we used 12, so we actually did net out slightly positive yesterday. I'm going to try to find, that was not a good day. That was an okay day. Saturday was a little better. Friday was partly sunny, but also my daughter is baking bread, so she was going crazy with our electric oven right here. So I'm gonna charge her for that. Let's see if I can find some good. I'm just trying to. This was a good day. Tuesday was a good day. we made about 20 and we used about 10. This was Monday, we made 20 and used about 10. So the cost of my system came in under $2 a watt. This is an incredibly good year to do solar because the tax credit is still around. It went on slightly, still pretty solid. I was able to get a 30% tax credit from the federal level. And you should absolutely get a quote on this, look into this. And in addition to that, Georgia Power is going to have to do a form of net metering because right now my payback is all based on the fact that every bit I sell, like you see on this day, I sold a lot of power back. And right now, by law, they have to buy it, but they don't have to pay much. So they're having to pay, let's be generous and say they're paying 4 cents a kilowatt hour for it. And then they're selling it to my neighbor next door for 12 cents a kilowatt hour. That's about how the numbers work out. So with net metering, what it means is up to the amount I use in a month, they will basically credit me full value for. So that's going to make the payback go even faster. Having said all that, a 4,000 watt array, $1.90 a watt is what I paid. That comes out to be about $7,500. I'm saving $560-ish dollars a year. I'm very happy with the simple payback on that. You can also borrow money and put no money down and still have positive cash flow. Why would you not want to do this? It really does make sense. So as I know that there are other obvious issues with that, but that's the short, sweet version of solar. Any other questions? Maybe what we'll do is we'll save solar questions to the end if that's okay. It's definitely exciting. I would absolutely recommend you look into it, especially this year. Okay. Let me see. And Atlanta, Georgia has a lot of good, very qualified, very talented solar installers. So they're really terrific. Oh yeah. If you're going to do a trade-off, last thing on trade-off, if you're going to do a trade-off, you, no matter what, cannot build a house this year that is worse than the house you could build last year. Okay, so yes, we're going to be opportunities to get credit for some stuff, but your house can be no worse than this. I call it the can't trade to zero. So, you know, you might be able to say, hey, I want to use R11 in my wall cavity. Nope, you can't. Any framed wall has to be at least 13. And any attic space with insulation, you have to have at least 30. You can't do less than that. If you're going to foam the roof line, you got to have at least 20. If you're going to do a hybrid system, it's 20 plus 5. If you're going to do a vaulted vented assembly, it's got to be at least 20. So these are the minimum that you can absolutely build with a trade-off. Hopefully that makes sense to everybody. And that's really not much of that's really just carried forward. Okay, the last big section I want to talk about is mechanical. There's some important changes here. Try to cut to the chase here. FYI, if anybody's installing heat pumps, and heat pumps today I think are a really good option, particularly I really like the mini split systems. I like any HVAC that has variable capability. It can automatically slow itself down. At the very least, slow down the blower. That's a good thing. We added a clarification in Georgia. It's always had this thing that says heat pumps aren't supposed to run the strip heat unless it's cold out. Well, basically what we did in Georgia, we defined cold as 40 degrees. So let me kind of give you, this is just a quick explanation of it. A house, when it's not cold out, 60 degrees, has very little load on it. And ironically enough, the heat pump can produce all kinds of heating at that temperature. As the temperature drops, the load on the house increases. That's the green line here. And just because of physics, as it gets colder out, the heat pump's ability to pump heat reduces. But if you look in this example here, as long as the temperature is above, and this is probably about 35 degrees, the heat pump is able to fully handle the heating load. In other words, we don't need any strip heat, any electric resistance toaster oven heat, which is very inefficient to operate. And it turns out it's really most of the winter hours, you're probably above this break-even point, which is called the balance point. If you get below it, so you can see if you're at 30 degrees out, most of the heating is provided by a heat pump. running the compressor. A little bit is provided by the strip heat. If it gets to be 20 degrees out, even at 20 degrees, half the energy is provided by the compressor and the rest is the strip heat. So what we did is we said, hey, look, any new home built to code, any home that's been renovated to code, you should not need the strip heat until you're at 40 degrees. A lot of houses with heat pumps, they're miswired, and it doesn't matter what the outdoor temperature is. If you change the thermostat on your heat pump more than 3 degrees, the strip heat turns on. And that's illegal, but that is done very frequently. I probably over-explained that, but hopefully you got it. No real changes on ducts. Ducts in the attic are R8. Elsewhere in a unconditioned R6. You have to insulate them with by code, and you have to seal them with mastic. That's a Georgia provision. And you cannot use a building cavity as a duct. That's a good thing. So some more language and some more graphics to show this, but honestly, no real changes from a performance, from a sealing standpoint. What did change was the tightness threshold. And oh, by the way, here's a very important one that you should fix on every home you visit, which is where the duct boot penetrates either the ceiling or the subfloor. You want to make sure that is either caulked or masticed or some way sealed, because that will show up as a blower door leak and as a duct leakage leak. So that's a very, as well as all the other places, but sometimes, you know, it's like, who owns that leak? Is it, you know, the painter? Is it the HVAC person? I don't know. Somebody's got to seal it. Okay. Leakage, I think I mentioned this, is 6%. And basically, you know, it can be tested at rough-in or tested at final. No real changes here. When do I not have to test a duct system? Number one is if you can get the ducts and the air handler completely inside the thermal envelope, that is a really good thing. As a carrot, we're not going to make you do a duct test. Earthcraft would still test it because we still see the value of testing it. But if it leaked, at least it leaked inside. If you have an existing home with an existing duct system, let's say you've got a bedroom that has comfort issues, and you have a subcontractor come in, they run an extra supply and 2 extra returns. Do those ducts need to be sealed with mastic? Absolutely. Do those ducts have to be insulated as per code? Absolutely. Are you required to make that duct system pass a leakage test? No. The magic number is 50%. If you mess with an existing duct system more than 50%, it has to pass a leakage test. And that's a good cutoff, because most of the time you're either doing a little bit to an existing duct system or you're gutting it and really not reusing much of it. So if you gut it, then you got to do it right and seal it and fix it to code. The only clarification here is if you replace just the equipment, let's say you put in a new furnace, a new air conditioner, or whatever, you have to seal the ducts that are already there, how deep? 5 feet upstream and downstream. So that's kind of the clarification, is the 5 feet. Okay. People that can do the test. The other big thing I wanted to mention was hot water. Hot water distribution turns out to be a very big energy waste, and a couple kind of guidance things for you. So first of all, the short answer is I'm going to recommend you should insulate any hot water pipe you can have access to. If you're running new hot water piping, smaller diameter pipes are better. They have less volume and they take less time to get hot water to the fixture. Ideally, your water heater is going to be located really close to the things that use it. If you've got a big home, it wouldn't be the worst thing to necessarily have 2 water heaters. But don't have a big home where 2 water heaters are sitting side by side in the basement. Put one on, you know what I mean? So try to put them close to where they're going to do good. There's also systems like a manifold system, or sometimes called a home run, where you come off the water heater and you want to come right off the water heater, you put a manifold and run a very small tube that goes to every fixture. What's nice about those tubes is they have so little cross-sectional area, there's very little volume, you get hot water very quickly. If in Georgia, it's a plumbing code requirement that if you're more than 50 feet of pipe between the water heater and the farthest fixture, you basically have to have a circulating system. And what I'm here to tell you is a circulating system is always going to have a pump somewhere. It could be at the water heater, or you can retrofit one at the farthest. And a lot of times they're controlled with a timer. And obviously those pipes need to be insulated. What is great is a retrofit of a demand-based recirculating system. And you can, one company is, their website is gothotwater.com. There's several companies. But anyway, the idea is this pump does not run on a timer, does not run on a temperature thing. It's not keeping hot water in the loop all the time. It's somebody walks in this bathroom and pushes the button, or a lot of times what we like to do is just put an occupancy sensor. If someone comes in the bathroom, there's a decent chance they might want hot water. Okay, so this little pump is going to essentially run and very quickly pump hot water from the water heater to that fixture, and it's going to circle it back through, a lot of times, the cold line or a dedicated return line. Either of those can work. And it's got a temperature sensor, and as soon as hot water is here, the pump shuts off. You can open the tap at any point in time, but the idea is that once hot water is at the farthest fixture, every other fixture is also going to have hot water. So you only have to have one pump. You can put a on-off device or a sensor in wherever you want. So this is a really great concept. And if you do an on-demand system, you're not required to insulate the pipes, although I recommend you always insulate hot water pipes. That was a very quick description. Here is technically what the code says about pipe insulation. Any pipe that's 3/4 inch nominal or bigger, any pipe that's outside your dwelling unit or outside the conditioned space, and a distribution manifold, or any buried piping, and any pipe in a circulating system except for demand control. All right, phew, I went fast. If you are required or are going to introduce fresh air into your home, that's a very good thing. I think you should. If you use, all your intakes and exhausts have to have dampers. If you use your main HVAC blower, it must have a more efficient ECM motor as a part of that, electrically commutated motor. That is, today, virtually every furnace has this. That was ahead here. And not necessarily every heat pump. So make sure you have that. If you're going to use your blower as part of your ventilation system, make sure it's got the efficient blower. Can you build a house too tight? We would say no, but you could forget to put in fresh air. So you can never build it too tight as long as you put fresh air. Why do we provide fresh air? To flush out pollutants and to give people new oxygen. How much fresh air? You get it from the IRC. You go, how many bedrooms do you have? How big a square footage? And it tells you, okay, you need that much ventilation. You can do it continuously, or you can do twice the amount half the time, or 3 times the amount a third of the time. You can suck air out of a house, you can push air into a house, or you can do both at the same time, and you'll get a different pressure on the house. We like exhaust fans, but we don't like them to run all the time in a humid climate like the South. So I'm a big fan of balanced or positive pressure. Make sure your bath fans duct to the outside by code, 100 CFM in the kitchen, 50 from the bathrooms, of course, ducted to the outside. Get Energy Star, they're quiet and efficient. Energy recovery ventilators are ways to do fresh air. This is where you have a fresh air stream coming in and you precondition it with the energy of the airstream that's leaving. That's my own house. I put one of those in and it works great and I love it. It's very low energy. I run it sometimes continuously, such as during a pandemic. Sometimes I open the windows and I run it intermittently. If you simply duct outside air into your return, of course, that has to be an ECM blower. That's a good way people do that. You want to use a motorized damper with a controller. That's an easy way to do it. This system will put positive pressure on the house when it operates. The controller makes sure it doesn't underventilate or overventilate in a given hour, which is a really nice thing. These are easy to retrofit. This is one that's also popular. It's like a bath fan running backwards. It's supplying air in. It's got a filter and it's got a temperature and moisture sensor. It'll move 50 CFM for the same energy as an LED light bulb. Very efficient, but it's designed to run all the time. But if the outdoor conditions are bad, it will underventilate on purpose, and you get to pick what bad is. So bad might be it's 90 degrees or hotter, or 40 degrees or colder, or above a certain humidity level or below a certain humidity level. So there's a lot of manufacturers of this concept, and I think there's a lot of future in this. The cat's pajamas, the Cadillac, the best option is probably a ventilating dehumidifier. These are more expensive, but they bring in fresh air and they pull in house air, mix it, filter it, and if needed, dry it and put it back into the house. This is really good as a Band-Aid for a house that's got a moisture problem. Obviously, do everything you can to fix drainage, but this is a really good approach. Or anybody with asthma or air quality issues, this is a great system because it really controls moisture. Some of the features I like, I've done every one of them. I like the smart controls that little inline supply fan have. I like energy recovery, particularly works well in the winter. I love supplemental drying. It could be its own dehumidifier or as part of that system. And of course, I want a good filter. To wrap up, I really am wrapping. Load calcs, we actually wrote a clarification that if you have right now or under old code, if you had a 3-ton load and you put a 4-ton air conditioner in, you've broken the law by oversizing. What we're going to say now is if you have a 3-ton load, you can put a 4-ton air conditioner in, provided it can automatically throttle back to less than the design load. So if it runs and it can throttle from 4 tons to say 2 or 2.5 tons, you have met code. So this is important because I think a lot of existing homes oversize. No change there. Last thing is lighting. I feel like I've covered that. Basically, the energy, here's a light fixture we encountered on our code survey. It had 9 60-watt light bulbs. If that was on 4 hours a day, that was $100 a year for that one light fixture. If those light fixtures were turned to LED bulbs, that would cost you about $16 for a year. So it's ridiculous how fast the payback is on LED. All right, I am done. Phew. And I will stick around and answer any questions. I almost made it by 4:10. Do we have any questions that you want to take in a priority, Catherine, or should we just go crazy?
The star at the top with Steve, his came in the longest to go.
Which one is that? Steve, okay, about
how difficult.
Well, I like to take them down every weekend and wash them and put them back up, Steve. So no, what they usually recommend is that if your roof is pretty well shot, then you might want to consider re-roofing that one area, re-shingling that one area, just so you start off at least with that area with a good roof. It can be done, but I don't want to have to do it, and because they fit into a racking system, and they've got that racking system figured out. So they've done a pretty good job with that. There really should not be a need to remove them. The solar panels are warranted for 25 years. They've been tested with hail on a flat roof. Mine are on a 10-12 slope. They say, really, you don't need to do much maintenance. You could go crazy and wash them, but honestly, I had some pollen buildup. We had some nice rain the last couple days. They're looking great. So we were fortunate. Our roof was fairly new. We had put it on a couple years ago, and it was I forget, it was an architectural shingle with a pretty good warranty, so I wasn't worried about it. Structurally, I have 2x4 rafters, and they run all the way down the roof, and they're spaced 24-inch on center. And Decatur said, yeah, no problem. So structurally, there's a little bit of a wind uplift issue, but not much. I actually went ahead and added some kickers for extra structure because I'm that guy. But structurally, it was amazing. Let's see, they're warranty for 25 years. They're going to last at least 30 years. So there's a long life on this. It's a really good investment. Okay, is it possible to do a decent sized DIY solar array? The question run away as soon as sorry. I would say that you can buy the panels really cheaply. you're going to probably want to get microinverters for every panel. Every panel with the microinverter, and you were able to get the actual real-time monitoring of my solar system, which is what I was showing you earlier, which is pretty amazing, because you actually see what each panel is producing, within 15 minutes of real time, which is amazing. Honestly, I think you could do that, but frankly, it's so cheap to have a contractor. We have some good contractors. I love to take on DIY projects. I did solar thermal on my own roof about 12 years ago. By the way, as much as I love solar hot water, today I would not do solar hot water. I would do solar panels. You can do more with electricity than you can with solar thermal, and there's less maintenance. So I probably would sub it out myself, but yeah, they've pretty much figured out how to do these. Liability might be an issue, and obviously you need an electrician for the electrical part. Okay, hopefully I answered that. Is it possible we typically use heat pumps for our basement remodels. Wonderful. Can you use a mini split for the same application? Yes, you can use a mini split. Mini splits are just an amazing technology. They offer incredible efficiencies that actually even regular ducted air source heat pumps don't have, particularly in the wintertime. Mini splits are just inherently they're almost always inverter driven, which means they can ramp up and ramp down. And they run a lot, but almost always on very low speed and very, very efficient. So they have good moisture removal. You can run more than one head. A head is the thing you see mounted on the wall. And there's also ductless mini splits, which you might have been talking about that. So there's, I'm trying to think what I was going to say. I got to not read the comments when I'm not answering them. But anyway, I'm a big advocate of mini splits. I think it's a great way to zone places. And yes, you can have more than one head or more than one ductless blower on a given heat pump. There's lots of ways to do it. Excuse me. Let's see. Next question. I was called on this 50-foot rule, and we are only at 30. Is that 50-minute rule?
Let me read you his initial question.
Okay, sorry. Go ahead.
He asked a question. I said, "Oh, did it get answered?" And he said, "No." So now I can't get the question back. So let me read it to you. Hang on, I gotta find it.
Sure, no problem.
It was about the wrapping the pipes. Hang on, I'm almost there.
Okay. Really quick, I'm going to answer the other one about. Really quick, Catherine. I'm going to answer this other one. My solar system is grid tied. It was $1.90 a square foot. That was after the tax credit. It was $2.70 a watt pre-tax credit. Today, you can beat that. You can come in better. And I was a participant in what's called a Solarize program. They're bringing it back to. It's been very successful around the state, bringing it back to Decatur. And that did not include battery storage. Battery storage is really exciting. It's definitely going to add cost, but this is where you are getting an additional feature. If you're going to go batteries, you probably want to do backup battery capability, because that way, if the power goes out, you can keep, critical circuits going, like refrigerators and things like that. So that is definitely going to add cost, but the battery technology has come way down. So whereas solar is already down, battery is getting there, and it's probably only going to get better. At the moment, I do not have that. So great question. So go ahead. I'm sorry, Catherine, and I will go back to the pipe.
So here we go.
One.
How does insulating the 3/4-inch hot water lines make sense when we are also required to install a recirculation pump and return lines? That seems more wasteful.
Yeah, not wasteful, because let me see let me hide this so I can see. So if you have a return line and you have that is, in other words, you're not using the cold water line, then you do not need to insulate the cold water line. You only need to insulate all the hot water lines and the hot water return line, because I think the comment would be that someone is saying it's lukewarm water, and it's just going back to the tank at lukewarm. And you know what? I'm going to say you're kind of right. I'm going to say go ahead and insulate it anyway, because it's part of the recirculating system. And a lot of times those are controlled by a timer as opposed to on demand. And if it's on a timer, then the return, let me try to draw this in here. This is going to be really ugly, so watch out for what you're about to see. But we're going to return line right here that does something like this. Oh man, it goes right back in right there. So you have your hot water line. Actually, I should have drawn the pump. It should have come right here. So the pump should be there. So pretend you don't see that right there. That's just a fly or something I stepped on. So the pump is circulating. The pump is circulating the hot water in this loop. And the pump, by the way, can be located over here at the water heater as well, which is on a new home, probably more likely where you'd see it, and maybe on a retrofit too. So the pump can be anywhere. But if it's timer-based controls, it does make sense that all of these hot water lines, including the one I drew, are insulated because you're keeping hot water in a pipe warm for, a couple hours of a day. A demand-based control, you can make an argument that maybe that doesn't have to be insulated. I would still insulate it. Pipe insulation's cheap. Just tell the plumber, anything with hot water in it, I want you to insulate it. And it, by the way, I didn't get a chance to explain why it actually saves energy. It has to do with how people use hot water. So if your house doesn't have a circulating system, somebody gets up in the morning and wants to take a shower, and so they run hot water until they get hot water at the shower. They take their shower and then they shut it off. And if this pipe is not insulated, it cools down pretty quickly. So, 40 minutes later, somebody else comes in and wants to take a shower. The pipe is cold and they got to start all over again. So you waste a lot of water as well as some energy. But if that pipe is insulated, it will stay hot for a good 30 minutes, maybe an hour even. So the next person coming through, they're able to get hot water there much quicker. So that's one of the big benefits of it. It's a convenience factor as well. Okay, I don't know if that answered your question, but what's the best way to circulate air when using mini split units? That's an interesting one. I was gonna, I have a friend that, some of you may know him, Carl Seville, who did a really efficient home. He lives close to me in Decatur here. And he used, I think, mini splits. And he was wondering if he was going to need like a transfer fan. So he had a capability of using a very quiet, I think it was a Panasonic bath fan that would not dump to the outside, but it would allow air in one room to kind of be able to be dumped back into a hallway or other parts of the room. And I think he did a great job on his shell. His thermal envelope is much better than code, which I of course would do as well. And I think he found that, air circulation wasn't as big of a deal. With mini splits, you're going to have to probably go to something like an ERV for your ventilation system. So an ERV that's independently ducted is a great way to make air circulate throughout the house for sort of fresh air reasons. I went fast on that, close enough from Steve. Okay, good. What's the next question on here? So some people have done transfer ducts. I think a lot of people have found that honestly, if the doors are open a reasonable amount of time and you've got a head in a bedroom and another one over here, it actually get decent circulation. But to be fair, the better insulated your shell is, the better your mini split, let's say air distribution issue is going to be. I don't think it's that big a deal if and ceiling fans are an option. I mean, there's, ways to circulate air, but that's kind of a halfway answer on that. Let's see, mini splits in main rooms want fresh air in bathroom. Fresh air in the bathroom. Usually if there's a room in the house that we are kind of willing to have be under negative pressure, at least for a burst of time, it's a bathroom. I was having trouble getting my kids to, run the bath fan long enough. So I wired it to the light switch, and I put the light switch, it was like $20, preset timer control light switch. I really like those in bathrooms because you go in and you push the button and it's going to run 10, 20, 40, or 60 minutes. And you can change the settings to your, and if you want, you can override it and shut it off. But it means that no matter what, when someone goes in there and they turn on the light, they're going to get at least 20 minutes of runtime, let's say. I think that's a better approach to guarantee, because if you're pulling air out of the bathroom, you're going to be pulling it in from elsewhere in the house. You know, worst case, if it really bothered you, you could put some sort of an exhaust fan on a timer control. There are ways to do that, that's automatically going to exhaust from the bathroom, say 10, 20 minutes an hour. But I would say that's a better approach than necessarily supplying makeup air into a bathroom. That's my take on that. Maybe there's more to it. Okay, with every basement we've done, the cost of a mini split system has been considerably more than a ducted heat pump. Yep. Multiple heads were needed. Yep. I like the efficiency and humidity control of the mini splits, but how to convince the client to spend considerably more for multi-split? I would just remind them that even though you did a great job, moisture control, basements have a bad habit of needing drying when they don't need any cooling. In other words, it's what we call a low load zone. And by the way, as we're building more and more high performance homes, you know, some of the real high end Earthcraft homes, for example, we're insulating the walls are R25 or better. The ceiling is incredibly well insulated with no penetration. The ducts are all inside. The windows are great and they have good orientation and, you know, good shading. There's almost no cooling load on a moderate day, but you find in the swing seasons, you still want drying. And I think I would try to push the benefit of the additional dehumidification that you get with mini splits, Gordon. I think that's a good option. The other thing would be to say, okay, you know, if we throw in the cost of a ventilating dehumidifier with this ducted system, you know, that's going to add cost, and the mini split might kind of offset that some. So, you know, it's definitely an upgrade cost. It's still kind of a premium product. It's ironic because only North America has ducted mechanical systems. The rest of the world uses mini splits. So it's still priced as a premium when it shouldn't be. But it's definitely becoming more common, and it's a great question. Okay.
All right, so I have one more.
Okay, what's that?
We need an HVAC consult for a house we renovated where the ductwork is condensing and dripping. Who might you suggest is appropriate to reach out to?
Thanks. Well, let's see. I always try to throw business towards anybody that is an Earthcraft technical advisor. They have gone through they have to go through pretty extensive training. You know, just to be qualified for that program, they have to be a home energy rater, and that's a pretty challenge. I mean, if they went through their training with us in particular, I know they earned it, and they have a lot of experience usually with addressing moisture issues. And so I would say there's also, I believe Georgia Power keeps a list, or used to keep a list of I think also maybe Cobb EMC, of sort of contractors that maybe have a little more experience with this. There's my home phone ringing, of course. Maybe my wife will pick that up for me. Yeah, we still have a landline. Yep, we sure do. And the phone is actually from the 1940s. So someone's giving me numbers. $1,500. Let's see. Heat pump is $4,500. Dehumidifier is $6,000. How much is the mini split? If someone's asking, I think you're probably just going to have to get some bids on this. And I'm a little wary of promoting an individual. We have some very good contractors, HVAC contractors. I'm not sure I should just go on the open air and push them, but you know, ping me with an email. I think my email's on the last slide, so and I'll help you if that's necessary. But I'm trying to find the last slide. It's Mike B at southface.org. But you know, the really good HVAC contractors have been through a lot of training with us, and you know, there are certainly quite a few HVAC contractors that all they do are existing homes because they don't want to try to get into the cutthroat world of new construction. And you probably deal with a lot of these guys, and a lot of times they can help figure it out. But you know, often when there's a condensation issue, and I'm not sure where was the condensation, assuming it was, say, on the surface of the duct or rather on the register, it means we're not drying the home properly. And anytime there's a moisture issue like that, you always want to know where's the moisture coming from. And quite frankly, a lot of times it comes from a dumb drainage problem or from a leaky house. A leaky house in our climate is going to let in a lot of air that's like today. It's just chock full of moisture. And when you bring in unwanted air, that's why air sealing helps dramatically as well. Air sealing helps you from over drying in the really cold winter nights. It helps you from over wetting in the humid days, of which we probably have a lot more of. So that's the, very, very crudely, very high level answering your question. If you can give us a little more detail, I can try to go deeper. I think I've killed everyone off.
There's a few left. Do you need to address the heat pump math question or?
The heat pump, I'm not sure I can give you the price on, maybe Mirko is maybe asking whoever asked the original question, if y'all can see the Q&A, maybe he's asking that. But I don't know is the answer. And,
okay.
I'm going to say, get a bid on it, get a quote on it. And maybe we can all kind of collectively work on our HVAC contractors to start bringing the price of the mini splits down, because I do feel like if it's priced still as more of a boutique item than it should be. And once it becomes more mainstream, which is happening, it's becoming more prevalent. It's not as I think it's a great technology. And I got to say, if I was, we don't run our air conditioner much. We keep our house I've improved our house enough to where we manage to stay cool. It's an old house with plaster and lath, so it's got a good mass in it. We mostly cool our house with believe it or not, a 8,000 BTU window unit, and circulate the air with some fans. So we're not trying to keep it 72 degrees either, but we know if we keep air moving and a little bit of dehumidification, we're pretty happy with it. So if I were putting in a new mechanical system, we only run our ducted AC whenever we have company. And if I were putting in a new mechanical system, I would probably put in a mini split. I'm pretty enamored of them. Although I have made my ducts pretty effective as well. So maybe not, I don't know. The key is variable speed. Anything that can slow itself down is gonna work more efficiently and usually leads to better moisture control. Okay, that was a guy who rambled on probably way longer than you wanted, Catherine, but I'll happily take any more questions, or you can email me. And also, do anything you can to support Southface, our starving nonprofit, would certainly be grateful. But I'm thrilled to have this opportunity to talk to y'all, Catherine. Thanks you so much for hosting.
Absolutely. I don't see any more questions coming through, so we'll let you off the hook.
Maybe next year we can all have live beer and building science or something like that.
Yeah. I love that. Well, thank you so much for your time today. And we'll get this thing closed out so people can get their evaluations done.
Excellent. Thanks, everybody. Really appreciate it.
All right. Thanks, Mike.
I'm going to stop sharing my screen. Let's see, stop sharing. And there you go.